All right, so this is the last worksheet for this unit. It's properties of transformations. So after you have completed this done with teacher, there is not a teacher station for this particular worksheet. You'll just go straight into the study guide and complete the study guide. The answers have been posted already. And then when you feel good and ready, go ahead and take the final exam. So properties of transformations. If a transformation produces an image with the same shape and size as the pre-image, the figures are congruent. Now, congruent is a big fancy word for the same. They're the same. They're equal. The symbol for congruency is an equal sign with a squiggle on top, just like that. A congruency statement for triangles could be shown as these two triangles here. So you always go typically in ABC order. So this one here would be A, B, C is congruent to triangle A prime, B prime, C prime. And that's how you write that. When you're talking about two images that are congruent, they are the same, they're equal, then that's how you write it. Now, if we're talking about similarities, if a transformation produces an image with proportional sides and congruent angles, the figures are similar. So if you're looking at these two triangles here, you can definitely tell that one is larger than the other, but you'll notice that they still have the same angle measures. This is still a 90, and then if you took a protractor, you can measure angle B and get the same angle measure here and measure angle C, and you get the same here. If you enlarge or reduce an image, the angles stay the same. Remember that. A similarity statement, or oops, I skipped one. The symbol for similarity is just the wiggle without the equals on it. All right, so on this one, we would say triangle ABC is similar to triangle A prime, B prime, C prime. So a good way to remember this is the one with the equal sign, they're equal in size and shape. The one without the equal sign means they're proportional, but the angles are the same. So let's look at number one. Describe the transformation shown here. All right, so let's look at our transformation. So this is the original. All right, and then this is the new image. All right, if you notice here that my A is here, but now it's over here, okay? And the same with my C. My C was here, and now it's on the left. So what obviously happened here? I'm going to say that this image flipped over. And when they flip, that's called a reflection. So we're going to say that the transformation shown here is a reflection over what axis? What did we jump over? We jumped over the y-axis. And let's look at B. What do you notice about corresponding side lengths and angles? So did the image change its size? No. Did the angles change? No. So I'm going to say that the sides and angles are congruent. Write a similarity or congruence statement. So since we're saying it's congruent, we're going to say that triangle ABC is congruent to triangle A prime, B prime, and C prime. All right, I'm gonna let you try number 2. So let's look at number 3. Number 3 says, use the figure below and follow the steps in the table. Include an algebraic representation of each transformation. For size, state whether the image is congruent or similar. For orientation, state whether it stayed the same or if it changed. All right, so we have several things to fill in here. First thing says, translate ABC 11 units left and 1 unit up. So I know if I'm going to the left, that's my x. So we're going to say x minus 11. I'm going to put this in coordinates here. And then it says 1 unit up, which is going to be y plus 1. All right. So if I do that, I'm going to take my a here, and I'm going to go 11 units to the left. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's going to put me right here. So I'm going to say A prime. Now let's look at my C. I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's going to be my C prime there. And then for my B, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's my B prime. All right, now with a straight edge, line those up and draw that out. Okay, so what can we say about the size? I'm going to say the size stayed the same, so this is congruent. And the orientation, did it change? Did it flip? Did it rotate? Anything like that? Nope, we're going to say stayed the same. Now we're going to reflect a new image over the x-axis. All right, so we're going to reflect this image, the new one, over the x. So this is, let me highlight, this is your x-axis. So we're going to literally just flip this upside down. All right, so that means we are going to keep our x, but make our y's negative. So the easiest way to do this is to get the coordinates. So I'm going to put, I need a little space here. My A prime is going to be -10, -9. So -10, -9. My B prime is -6, -3. And my C prime is -2, -9. So what am I going to keep? I'm going to keep all of these x's. These numbers stay. And then I'm going to take the opposite of all of this. So instead of -9, it'll be +9. Instead of -3, +3. All right, let's draw my new one. So I'm going to keep -10, but now I'm going to go to +9. And I don't know what you would call this, maybe A prime prime. Let's just do that. All right, my B would be -6, but now +3. And then my C would be -2, but +9. Line that up. There we go. So what did you notice about the size? Did the size of the triangle change? No. So we're going to say that is congruent. How about the orientation? Did it move? Did it change? Did it rotate? Flipped? Yeah, it did. So this one was a change. It flipped. All right, I'm going to let you guys practice these last two here. And then I'll meet you here on number 4. So number 4 says, the examples below show an image after a series of 2 transformations. identify the two transformations that took place. All right, so I like to always highlight the original. So we went from it looking like this to then over here. How did it get from here to there? So the first thing I might say is that it slid down. Let's slide it down first. So how many units down did we go? I'm going to take this top point here, and I'm going to take this top point here. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a drop of 9 on the y. So my y is minus 9. Now what's my x? Now my x went from here to, let's compare these two. All right, so this went from 3. Okay, so 1, 2, 3, 4, 5. So that's a difference of a 5. I think we're looking here that it definitely dropped down by 9, but it shifted. Well, if you just look at it actually real quick, this is even easier. Do you see how this is 3 boxes over and then this here is just 2 boxes over? So it shifted to the left 1 box. That's just easier to say it that way. So we're going to say that our x went to the left 1. So the first thing we can say is that if it came down here, it slid, which is a translation, where it went 9 down and 1 left. All right, so if you picture this image hanging out right here, let's say, I'm just kind of drawing this makeshiftly. All right, how did it get from this orientation to that orientation? What did it do? It obviously flipped over, or it reflected. So we're going to say then it had a reflection over. All right, what axis did I just cross over? I crossed over the y-axis. All right, let's try one more. Let's do number 5. So 5 is here. This is my original. And then I'm changing to this. So the first thing I notice right away is that it's upside down. And I'm going to go with we're turning it. All right. So remember, each box that you rotate through is 90 degrees, each coordinates. So if I go from this box, this coordinate to this coordinate, that's 90. And then if I go from this quadrant to this quadrant, that's 90. So I'm going to say right now it's rotated 180 degrees. So my first thing is there was definitely a rotation of 180 degrees. Now, did it stay in the same location as far as how far away from the X and Y it is? So this one here is over 3 up 1. This one here is over 5 down 2. So I'm going to say that its location then slid. So it got over to the correct place and then it slid over just slightly. So that's a translation. And obviously we went from 3 to 5. So that's a translation of 2 to the left. And then I went from up 1 box to down 2 boxes. So that's also 1 down. All right, I'm going to let you guys try number 6. And of course, you can skip the summary.